welcome back. We're going to be looking at chapter 2.6, page 144, and our exercise is going to be golfing in the moon. And it's an interesting exercise. It's based on an actual event. In 1971, Alan Shepard, who was the first American to go into space, was on the moon. And while he was on the moon, he picked up a stick that they were using for exploration purposes.
Here's the one you're looking at up. You might recognize what I have in my hand is the handle for the example return. I just still happens to have a...
And he took a small white pellet, which you're going to see him drop in just a second, and proceeded to go golfing. Whoops, sorry about that.
Stand by. Here's the one you're looking at up. You might recognize what I have in my hand is the handle for the example return. I just still happens to have a 8-inch fixed iron in the bottom of it. In my left hand, I have a little white pellet that's familiar to millions of Americans. Kind of drop it down. Unfortunately, since it's so stiff, I can't do this with two hands, but I'm going to try a little sand trap shot here.
Good, Mr. Shepard. Thank you. So let's take a look at the problem that you were given on page 244. Oh, and I'm filling through here. Let me see. Let's go to... There we go. So you're given a description, one of those word problem things, and you're supposed to figure out what function is the correct function for that word problem. So in 1971, astronaut Alan Shepard hit a golf ball on the moon. He hit the ball at an angle of 45 degrees with a speed of 100 feet per second. The acceleration of the ball due to gravity on the moon is 5.3 per second squared. Then the ball landed. And so the problem solution is represented by one of these four functions, and you're supposed to figure out which function is the right function. And I'm going to show you something, kind of a way to kind of cheat this a little bit. It goes back to what you guys learned in chapter 1. Now, let's think about what this scenario is going to look like. You're going to hit a golf ball. Now, you know what it's going to look like. The ball is going to go up, it's going to flatten out, curve, and it's going to come down plump. It's going to land. And that looks like something. If you think about that for just a second, it looks like something you've seen before. That is a quadratic function. You know what that looks like. Imagine if that's an xy coordinate and you see that, you know that's a quadratic function. Now, you remember quadratic functions are going to look like something like this. All right, that's how they're going to be formatted. So let's take a look at our functions and see if we have any winners. We're not going to have to do the math. We can just look and see which one looks like a quadratic function. Now this first guy, function of d is 5.3d. And what we're actually calculating here is, okay, if you're so far out this way, the ball is so far away, how high is the ball in the air? Okay? So if we take a look at this first one, 5.3d, and d is the distance it's going this way, let's think about that for just a second. Here's what that's going to look like. At, let's say 10 feet, we multiply it times 10. It's going to be there. And then 20, it's going to be there. And then 30, it's going to be there. And 40, it's going to be there. If that's looking familiar, it should. That's a linear function. There is no way that's going to happen. He's not going to hit the ball and it's just going to keep on going forever. Even on the moon, it's going to come down eventually. So let's look at our second one. Whoa. Oh, wait a minute here. 100 d, we're going to put the d as an exponent plus 5.3. Let's think about that for a second. So you have 100 to some exponent power plus 5.3. Let's just say for the sake of argument that we're 100 feet out. So this would be 100 to the 100th power. That would be 100 times 100 times 100 times 100 times 100, and so on and so on and so on. That's going to take off like that. And is it ever coming down? No, it is not coming down, okay? That's an exponential function. That's not going to work. This one, not even going to look at it. You know why? Think back to chapter 1. What are you looking at here? Those are absolute value bars. And you know what an absolute value function from working in chapter 1 is going to look like. It's either going to do this, or it's going to do, it's going to do this. It's going to be a V shape, and it's going to be up or down. Now you tell me, does that look like a golf ball going up and coming down? Not even close. So that leaves us our last one. Where is that puppy at? There he is. Sorry, he's hiding on me here. See if I can get him to come up. Come up. There we go. Ah. Negative 5.3 over 10,000 b squared plus d. Now, take your calculator out and let's put 100 feet right here. No, I'm sorry. Let's put that's the exponent. Let's put 100 feet here and 100 feet here. And what happens when you crunch the math, that's 100 squared. You're going to come out to a real nice figure that's very reasonable. And if you keep crunching the numbers on the chart that's in your book, the numbers are going to go up, and then eventually the numbers are going to come down. If you take it out far enough, it would actually come back down to 0. So, I'd like to take a moment to thank the Apollo program for helping us with today's lesson.